guys, it's Miss Neal. Hopefully this is going to work and it'll be a little bit easier for you if I do this on the daily basis. So today is September 10th. Today we are going to start a new unit. So we're starting a unit on geology. Your tasks for today are to complete your notes through the evidence on continental drift, turn in the analyzing evidence worksheet, complete and turn in the Pangea lab, and then do your exit ticket. So I'm going to click on this folder and we're going to get started. All right, so that did not work. We'll look at it small. So oceans cover 71% of our planet. They're more populous than land on our planet. Actually, in the southern hemisphere, 80% of the world down there is ocean. If you think about it, there's really not much there in the form of land. You've got some of South America, you've got some of Africa. Most of your land is up in Europe and Asia. All of that's going to be in your northern hemisphere. Only 20% of the northern hemisphere is ocean. So again, like I said, Europe, Asia, North America, all of that's land. We've got 4 ocean basins. We've got the Pacific, the Atlantic, the Indian, and the Arctic. The Pacific is the biggest, the deepest, and the largest of all of the ocean basins. If you combine the Atlantic and the Indian and the Arctic, it would be about the same size as the Pacific. The Arctic is the smallest and the shallowest. The Arctic Ocean is at the North Pole. The South Pole is actually a continent. It's a landmass. Its name is Antarctica. All of the oceans in the world are connected, so they're not actually individual bodies of water. Like you saw with the currents, they're all traveling and sharing, and things can actually move from one side of the world to the other by the oceans. So Christopher Columbus was right. You can indeed sail around the entire world. So Alfred Wegener in 1912 came up with this idea called continental drift. And he said that all the continents at one point in time, a long time ago, were conjoined. And that supercontinent was called Pangea. He said that there was a lot of evidence for this. He said that the shape of the continents gives way and gives credence to this, that the continents all somehow fit together in this giant puzzle. He said once you fit the continents together in this puzzle, we have lines of mineral deposits that all match up. And even though they're separated in different parts of the world now, those mineral deposits are still in the same places. He also said the fossils do the same thing. So we have fossils that you find in Africa on the southern tip and also in the southern area of South America. And even though they're no longer connected, if they had once been connected, that would have been the area where they were. In 1912, though, a lot of the world were skeptics. He wasn't believed because he couldn't prove how the world moved. How did the continents move? Nobody knew at the time, so nobody believed Alfred Wegener. It wasn't until later that we had evidence in order to prove Alfred Wegener right. So today we're going to go on a mission and pretend like we're in 1912, and we're going to attempt to follow Alfred Wegener's train of thought. So that was all you needed for your notes. You're going to go back to this main folder, and you're going to go to this Analyzing Evidence worksheet. You can do this in one of 2 ways. You can save it as a PDF and edit the PDF, or I also gave it to you as a PowerPoint. You can click on the PowerPoint, and there is the assignment right there. You can save this PowerPoint to your computer. Once you save it, so you would just File, Save As, and pick where you want to save it to your computer. So Continental Drift 2 sounds great as the name. I'm going to save it to my desktop. That way I can find it. If you want to make a folder that says like Marine and Aquatics, that would be a great place to save things to. I'm going to save it to there. Now I can edit this. So what it wants to know is it evidence or not? So we're going to look at it. So the first one says, in 1858, geologist Edward Suess points out that fossils of the Glossopteris plant are found in southern Africa, South America, Australia, Antarctica, and India. So you need to decide if that supports the idea of Pangaea and that the continents were once divided or once adjoined and they've moved, or if it doesn't support that idea. So evidence is something that's hard, that we can touch. It's not a theory, it's not an idea, it's something concrete. So we can concretely look at fossils and where they're located. So this would be evidence. I need to mark it on this sheet. So I'm going to go to Insert. I'm going to go to Text Box. I'm going to put a text box under Yes, and you can mark it with whatever symbol you want. I'll just put a big X there. And then we need to decide if it supports the idea that the continents have moved. Well, Seuss pointed out that they were all found in that same area, and now none of those things are connected. But then how did they get to the same place if they aren't connected? So it definitely supports the idea. So we're going to go up here to text box again. We're going to enter a text box, and I'm going to put a big X in it because it supports the idea. Then we're going to go to the next statement. Wegener examines the location of tiny rocks and the direction of grooves formed by large glaciers scraping across southern areas of Africa, South America, Australia, Antarctica, and India. He concludes that if all these places were fitted together, they would form a continuous ice sheet expanding out in all directions. So you need to decide if it's evidence, yes or no, and does it support the idea that the continents have moved? Yes or no. When you finish going through this worksheet, you're going to save it. You're going to make sure under submissions, yours looks different than mine because I have the teacher view. But you're going to go over here and you can attach the file and send that file back to me. You can either attach it as a PDF if you did it as a PDF, or if you saved it to your computer, you can upload it as a file. After that, we need to do the Pangaea Lab. So we're going to open up the Pangaea Lab. It says open the OneDrive file and follow the directions. The link for the lab is listed on OneDrive and on Schoology. So I'm going to click the link. And here it is in Microsoft Word. I need to save this document to my computer. I'm going to edit the document, and then I'm going to upload it back to Miss Neal. So I'm going to do the same thing. I'm going to go to File, Save As, and you can pick however you want to do it. You can, I would say, download a copy to your computer. Download a copy. Open. And then I have it in Microsoft Word. I can close it over here. Give me just a second to see it again. Here it is. I've got it in Microsoft Word. I can save it to my desktop. File, Save As. I got the spinning wheel of death. This isn't good. Glencoe Pangaea Lab. I want to move this to my desktop so I can find it when I need to turn it back into Miss Neal. And I'm going to save it. Now I can edit this document. So the first instruction is go to the following link. You're going to click on the very first one, and it says, what evidence supports Pangaea Lab? Where it says click to enable Flash Player, you're going to click and allow that Flash Player. And then you're going to follow the directions. So it says follow the instructions, continue trying until you build Pangaea. This is hard. Be patient. It's going to take lots of tries. There's a reason you have 90 minutes. You shouldn't get this on the first try. You might not get it on the second or third or fourth or fifth try. If you are a distance learner, once you get Pangaea built, take a picture of it, take a screenshot of it, whatever you can take a picture with your camera, and submit it to me through an email or through a message on Schoology. That way I know you actually did the lab and you didn't just Google the answers. I'm sure you could print a copy of the screen if you wanted to do that. That would work as well. So you're going to go over here and you can turn on and off the different fossils on the different continents. And you can pick the different shapes. And you're going to move them to the map until you can get them moved to match. So let's say here's Australia, and I think a million years ago Australia might have looked like that. So I'm going to move Australia kind of where it goes on the map, and I'm going to go to the next continent. Here's Eurasia. I can go to this puzzle piece and pick what I want Eurasia to look like. I'm going to leave it like it is. And I'm going to pull it up and put it on the map. And remember, you're trying to build this like a puzzle. So you want your pieces to match. You also want your fossils to line up. So I wouldn't put India right here because that yellow doesn't match anything here and that's blue. So that piece doesn't go there. I can just put it in the puzzle box. Here's North America. That could work. When you're done, I'm just going to throw some continents up there really quick. This is by no means the right answer. When you're done, you can press check. And it'll highlight the ones that are wrong for you. You can move them to the puzzle box, and you can start again. You're going to turn all of that into me today and do your exit ticket. I hope that clears up any confusion you might have about how to do a lab. Make sure you answer the questions, like I said, at the bottom. Make sure you answer these questions. Also, make sure you submit a picture to me somehow of what your finished Pangea looks like. I hope you have a great day, and I'll see you soon.